The sun hung low over the Tunisian desert, a blinding white disk above endless sand and broken rock. It was February 1943, and the smoke from the Battle of Kasserine still drifted across the valleys. German patrols moved cautiously through the scattered wreckage of American vehicles, picking over what remained after the chaotic retreat. Most of it was familiar by now. Sherman hulls burned to the frame, wrecked M3 Stuarts half buried in sand, ration boxes, helmets, boots, and the strange collection of American equipment that always seemed too new, too fresh, too plentiful. But on that particular morning, one machine stood out. A German recovery team approached a vehicle sitting half-sunken beside a dried riverbed. It was not a tank, it was not a truck, it was something in between, something the Germans had seen before but never truly examined. A long-hulled, half-wheeled, half-tracked armored troop carrier with open-top sides and stamped metal fenders. The white star on the side was scorched, but still visible. An American M3 half-track. Its crew had abandoned it after the engine quit during the retreat. The Germans expected nothing special. To them, American vehicles were crude boxes of steel meant for mass production, but their orders were clear. Anything intact enough to tow was to be brought back for evaluation. So the recovery team hitched cables around the front bumper, pulled the half-track free, and watched with mild surprise as it rolled easily behind the SDKFZ prime mover. Even dead, the American vehicle moved with a strange smoothness. By the time the M3 reached the field workshop near Sfax, several German mechanics had gathered around it, curious but unimpressed. The SDKFZ 251, their own half-track, was a machine of precision engineering. Its sloped armor, complex running gear, and carefully designed interior were sources of pride for German crews. The Americans, they thought, could not possibly have built something comparable. But as the first bolts came loose and the first inspection panels dropped away, their confidence began to waver. Something was different here. Something unexpected. Something unsettling. The frame was simple, shockingly simple. Instead of custom-built armored components, the M3 used reinforced versions of ordinary truck parts. The engine was not a specialized military design, but a heavy-duty commercial model, nearly identical to those used in American freight trucks. The transmission was straightforward, the electrical system uncomplicated, and the fuel lines were arranged so cleanly that repairs could be performed in minutes. One German engineer ran his hand across the engine block and frowned. "This should not be here," he muttered. "This is a civilian engine." Another mechanic opened the storage compartments along the hull and froze. The spare parts included items that looked like they had come straight off a factory floor back in Detroit or Cleveland. Not military issue, not custom-built, not carefully machined components that took weeks to produce. Just ordinary, mass-produced parts. The realization spread quickly among the technicians. The Americans had built a frontline armored vehicle almost entirely from civilian production components. And not only that, they had built it in a way that any soldier with basic mechanical knowledge could repair. A cracked radiator hose could be replaced with a spare meant for a commercial truck. A damaged side panel could be swapped with nothing more than a wrench and a few bolts. The German engineers exchanged uneasy glances. Their own half-track, the SDKFZ 251, was a masterpiece of engineering, but a nightmare to maintain in the field. Its armored body required careful welding. Its engine demanded precision repairs. Components had to be shipped from specific factories deep inside Germany. A simple breakdown could immobilize the vehicle for days, sometimes weeks. But the M3 was different. It was not elegant, it was not refined, but it was unreasonably practical. The more they opened it, the more the Germans understood what they were truly looking at. This was not just a troop carrier. This was an industrial message, a declaration of how the United States intended to wage war. One officer arrived to inspect the captured vehicle. He looked over the open-top troop compartment, the bench seats, the racks for equipment. He noted how quickly the gun mount could be changed, how easily the vehicle could be fitted for new roles: ambulance, troop carrier, command vehicle, artillery tractor, anti-aircraft platform. All from the same basic shape, the same basic parts. The Germans had spent years designing specialized vehicles for each of those roles. Each vehicle had its own factory, its own blueprints, its own unique components. The Americans needed only one. As the desert wind blew dust across the workshop floor, the German engineers found themselves staring at a vehicle that should not have been impressive, but was. Not because it was advanced, not because it was heavily armored, but because it was the perfect embodiment of a philosophy Germany had never embraced. Simplicity as strength, production as power, practicality as superiority. In that quiet workshop in Tunisia, surrounded by sand, tools, and the distant thunder of artillery, the truth settled heavily on the German technicians. The Americans were not winning because their machines were better. They were winning because their machines were simpler, and because they could build 50 of these for every one Germany produced. The captured M3 half-track had arrived as a trophy. It left as a warning. When German engineers began disassembling the captured M3 half-track in the workshop outside Sfax, they expected the same complexity and precision machining that defined their own armored vehicles. Instead, they found something that felt almost like an engineering insult to everything Germany believed about military design. It was as if the Americans had asked themselves one question before building the M3. What is the simplest machine that can do every job we need? And then they built exactly that, with no ornament, no excessive shaping of armor, and no obsession with mechanical perfection. The M3 was blunt, direct, almost crude. And yet, as the Germans studied it piece by piece, a sense of unease crept through the room. Because every single part of the M3 was simple for a reason. Every design choice served speed of production, ease of repair, and battlefield flexibility. Nothing was wasted, nothing was overbuilt, nothing was fragile. The heart of the vehicle, its engine, stunned the German officers most of all. At a time when Germany was pouring resources into specialized Maybach engines for its armored fleet, the M3 used engines built by White or Hercules, both of which came straight from commercial truck factories in the United States. These engines were not masterpieces of precision engineering. They were straightforward, rugged, and already being produced in enormous quantities for civilian industry before the war. When the Americans needed military vehicles, they simply adapted what they already had. To a German automotive engineer, this was nearly unthinkable. German military engines required precise machining, refined materials, and skilled labor from limited factories. Their output was inherently restricted. But the Americans had thousands of factories capable of producing similar engines without slowing down civilian industry. The M3 half-track represented a kind of industrial power Germany could not match. The suspension system revealed the same philosophy. German half-tracks like the SDKFZ 251 used complex overlapping road wheels and carefully engineered tracks that required constant maintenance and frequent spare parts. The Americans, in contrast, used a simple front axle from a standard truck and a rear track system based on commercial tractor designs. The tracks themselves were rubber-based and could be replaced quickly. The Germans soon discovered that even badly worn American tracks remained functional longer than expected, something impossible with their own machines. One German mechanic shook his head as he inspected the suspension. "How is this so simple?" he asked. "And why does it still work?" The hull of the M3 was another revelation. Instead of heavy, intricately welded armor plates, the Americans used thinner, rolled steel sections that could be stamped, cut, and bolted in place in minutes. This armor would not stop a high-caliber round, but it was never meant to. The M3 was designed to move troops and equipment, not to fight tanks. What mattered was that the armor protected against shrapnel, rifle fire, and debris. In this role, the M3 was more than adequate. Most importantly, because the armor was thin and its shape simple, factories could produce the hulls at incredible speed. The Germans realized something else as they studied the interior layout. The troop compartment was designed with straight lines and flat surfaces so that the benches, racks, and storage boxes could be installed without welding. Everything bolted together. Everything could be removed, replaced, or repurposed in the field. A squad leader could reconfigure his M3 in less than an hour. The Germans needed specialized workshops to perform similar adjustments. Then there was the equipment. The Americans had mounted the machine gun on a skate rail that ran around the inside of the troop compartment. Soldiers could move the gun from one position to another in seconds. German engineers examined this with disbelief. Their own half-tracks either required fixed mountings or slow adjustments with tools. Here the Americans had created a system that required no tools at all. The deeper the Germans looked, the more the pattern became impossible to ignore. Every component of the M3 was chosen not to be perfect, but to be available, not to be elegant, but to be functional, not to be unique, but to be compatible with hundreds of thousands of civilian trucks and vehicles already in American production. This was not engineering weakness, it was engineering genius shaped by industrial reality. Germany built machines for performance. America built machines for war. The contrast was brutal. German vehicles were works of craftsmanship. Each one consumed enormous time, labor, and material. Spare parts were limited. Repairs were slow. Production could never keep up with battlefield losses. Meanwhile, the Americans were creating vehicles like the M3 that could be built on an assembly line by semi-skilled workers at a rate Germany could not hope to match. When the German engineers finished their initial inspection, one of the senior officers wrote a short note in his report. It was a simple observation, almost casual in tone, but it carried the weight of strategic realization. He wrote, "The Americans have engineered this vehicle not to be superior, but to exist in great numbers. And in war, numbers are the true measure of advantage." The M3 was not a technological marvel. It was something far more dangerous to German ambitions. It was a symbol of a nation that understood how modern war was truly fought, not through complexity, but through production, not through perfection, but through practicality, not through rare machines, but through machines that could be built by the tens of thousands. In the design of the M3 half-track, the Germans saw the truth they had been ignoring for too long. The Americans were not winning because of better soldiers or better armor. They were winning because they had mastered the art of simple solutions at industrial scale. And the M3 half-track was proof that simplicity, when multiplied across an entire army, was a weapon far more powerful than Germany had ever imagined. When the Germans finished their initial inspection in Tunisia, they shipped the captured M3 half-track to Europe for deeper evaluation. The vehicle arrived first at a logistics depot near Naples and later at a technical testing ground in occupied France. There, away from the battlefield noise, the Wehrmacht engineers could study not only what the M3 was, but what it could do. What they discovered in the following weeks shocked them far more than the simplicity of its construction. They learned that the M3 was not just easy to build, it was nearly impossible to stop. The first series of tests involved basic endurance. The Germans fueled the M3, checked the oil, and drove it around the perimeter track. They expected it to fail early. They assumed the rubber-based tracks would wear out. They assumed the civilian engine would overheat in European summer weather. They assumed the simple suspension would not handle rough terrain. But the M3 defied every expectation. The German drivers pushed it across gravel, mud, waterlogged earth, and roads filled with holes. They drove it through deep ruts carved by tanks. They climbed steep inclines designed to test Panzer chassis. The M3 did all of this not with elegance, but with stubborn endurance. It rattled, it shook, it bounced, but it kept going. One German test driver remarked that the M3 felt like a farm tractor with armor plates bolted on. Yet even he admitted that the damn thing refuses to break. The deeper the Germans went into field trials, the more their respect grew. They discovered that even if the tracks were damaged, the vehicle could still move on its front wheels long enough to get out of danger. If the radiator leaked, a handful of basic materials could patch it. If the electrical system shorted, any soldier with pliers could reroute the wiring. Every failure was easy to fix. Every fix took minutes instead of hours. The Germans ran one of the harshest tests they had. They drained the engine oil, ran the M3 for several minutes, then refilled it. The engine sputtered but recovered. They attempted the same test on one of their own SDKFZ vehicles and destroyed the engine within seconds. That moment made several of the German engineers fall silent. The ruggedness of American automotive engineering was something they had underestimated badly. Then they tested the M3 in simulated battlefield conditions. They loaded it with a full squad of German infantry, assigned a machine gun crew to operate the ring mount, and sent the vehicle through a mock combat course lined with trenches, debris, and shell craters. The M3 moved smoothly, allowing the infantry to dismount quickly and without confusion. The machine gun transversed with almost no effort. The interior space, though simple, allowed rapid movement. The German soldiers admitted, reluctantly, that the M3 offered more room and easier firing angles than their own SDKFZ-251. One officer noted that the M3 seemed built around the needs of the soldier, not the preferences of the engineer. This was a rare compliment from a German staff officer. German vehicles prioritized mechanical quality. American vehicles prioritized the human being who had to use them. The next stage of testing involved repair trials. The Germans intentionally damaged the vehicle. They punctured fuel lines, they disconnected electrical systems, they removed belts, hoses, and bolts. Then they asked an average mechanic to restore functionality using only field tools. The repairs took minutes, not hours, not days, minutes. The mechanics looked both impressed and unsettled. The Americans had built a machine that demanded almost nothing from the people who maintained it. In contrast, repairing the SDKFZ-251 required trained specialists, specific tools, and often access to a proper workshop. The Germans could not move their half-tracks quickly from one battlefield to another because each breakdown became a logistical nightmare. But the M3, as the tests proved repeatedly, could be repaired anywhere, by anyone, with anything. Small accidents that would immobilize a German vehicle for days barely slowed the M3 at all. A crack in the exhaust system was fixed with a strip of metal wire. A broken headlight was replaced with a standard bulb. A damaged seat was repaired with canvas straps. Every time the Germans found themselves asking the same question: why did we not build something like this? One mechanic wrote a frustrated note in the test report. This vehicle is not built to last forever. It is built to last long enough, and that is all a soldier truly needs. The most alarming discovery came during the towing tests. The Germans attached a 75mm anti-tank gun behind the M3 and drove it across muddy terrain. The half-track pulled the gun with no difficulty. They added another gun. It still pulled. Then they attached a small artillery piece used by German mountain troops. Again, the M3 pulled it without hesitation. This versatility shocked the test officers. Germany needed 3 different vehicles to perform the same roles. The Americans needed only one. At the end of a full month of testing, the German engineering staff compiled their findings into a classified report. It was blunt, direct, and deeply troubling to German command. One sentence stood out: the American M3 is not superior to our SDKFZ in quality, but it is infinitely superior in function. The report concluded with a chilling assessment. If the Americans can produce these vehicles faster than we can destroy them, they will eventually overwhelm us with mobility alone. And that was the truth. Germany had been running from since the beginning of the war. The tank battles, the great offensives, the dramatic breakthroughs, none of them mattered without logistics. And the Americans, through the M3 half-track, had revealed the secret of their success. They had created a vehicle that could move an army forward without stopping. A vehicle that made their infantry faster, their artillery more flexible, and their supply lines almost impossible to break. The M3 was not the strongest machine on the battlefield. It was simply the one that never stopped. and that made it more dangerous than any German engineer had ever imagined. When the reports from the testing grounds reached higher German command, the reaction was not disbelief. It was something far more dangerous. Quiet, dawning recognition. Officers, engineers, and staff planners gathered around the captured M3 half-track as if it were a strange artifact from another world. It did not look impressive. It did not intimidate anyone. But the more they studied it, the more they realized they were staring at the physical proof of a truth they had ignored for too long. The Americans were not fighting the same war Germany was fighting. They were fighting a war shaped entirely around industry, standardization, modularity, and speed. The contrast between the two nations became painfully clear when the Germans placed the M3 side by side with their own Sodkev Z251. The Sodkev Z was a technical masterpiece, designed by some of Germany's finest engineers. It had sloped armor, a refined suspension, and a unique hull shape that required expert welders. It was the kind of machine Germany believed represented superiority. But the M3, with its straight plates, stamped parts, and truck-derived components, represented something else. It represented a nation that had embraced the reality of mass production. German officers walked around the two vehicles in silence, their boots crunching on the gravel floor of the workshop. One officer stopped beside the Sodkev Z251 and tapped the armored hull with his knuckles. "This takes weeks to build," he said. Then he pointed at the M3. "That takes days." The engineers nodded. The Americans had created a machine that could be built faster than German factories could even prepare materials for their own vehicles. A logistics officer added another observation. Germany had designed multiple specialized vehicles for different roles. The Americans had designed one platform that could be turned into anything. This single idea rattled German planners more than any tank battle could have. The M3 could serve as a troop carrier, artillery tractor, medical transport, reconnaissance vehicle, command post, radio carrier, or anti-aircraft platform. Germany required separate designs for each of these roles. One half-track, one engine, one set of parts, one training program. The Americans could build an entire mechanized army from a single blueprint. That was the secret Germany had never understood. The Germans decided to run versatility trials, hoping to prove that a general-purpose vehicle could not match the performance of their specialized machines. But test after test refused to support that belief. The M3 performed well enough in every role, moving troops, towing guns, carrying ammunition, and functioning as a simple armored fighting position when needed. It did not need to be perfect. It only needed to be good enough. Good enough multiplied by tens of thousands was a kind of power Germany could not match. The psychological impact was enormous. For years, German soldiers assumed the Americans were technically inferior. They assumed American vehicles were clumsy and cheaply made. They assumed American success came from numbers alone, without skill or craftsmanship. But the M3 half-track forced a re-evaluation. Now the Germans understood that American strength came not from crude mass production, but from intentional simplicity. It came from designs that eliminated weak points, reduced production time, and allowed untrained crews to keep machines running under any conditions. One German engineer studying the machine gun skate rail inside the M3 gave an unexpected compliment. "This is genius," he said. "The gun can move anywhere along the rails without tools. Our crews must unbolt and remount their weapons. The Americans simply slide it." That remark captured the shift in German thinking. They began to see that American equipment was designed with the soldier in mind. Comfort, efficiency, and ease of use were not weaknesses. They were advantages that kept American troops alive and moving long after German vehicles failed. The Germans later brought in artillery officers to evaluate the half-track as a towing platform. They tested it with captured American guns, German guns, and even heavy loads meant for larger vehicles. The M3 handled everything with steady reliability. The officers, accustomed to the complex towing logistics of German artillery units, were stunned.
The Americans had built a single vehicle that could support nearly every type of battlefield weapon. One officer quietly admitted something that many already knew but refused to say aloud. The Americans understand war better than we do. The Germans also noticed something else. American maintenance manuals were written clearly with diagrams that even a civilian worker could follow. German manuals were often dense, technical, and written for mechanics with formal training. Standing beneath the open engine compartment of the M3, a young German technician held one of the American manuals and shook his head. He joked that even his nephew could repair this. But beneath the humor was a deep realization. The Americans had created an army where anyone could fix anything. Germany had created an army that required experts they didn't have enough of. As weeks passed, the German engineers compiled detailed reports for the High Command. But some of the most powerful observations were never written. They were simply spoken quietly among the staff. The Americans choose not to make things complicated. They choose not to chase perfection. They choose to build what works. And that was the core of the shock. Germany believed its engineering philosophy was superior: precision, complexity, uniqueness. But in the captured M3 half-track, they saw a philosophy that was better suited for the realities of global war. Simplicity meant scale. Simplicity meant reliability. Simplicity meant mobility. And mobility, above all, was what won campaigns. By the time the evaluation ended, the M3 had done more than reveal American engineering choices. It had revealed American strategy. The United States had chosen to fight a war where factories mattered more than finesse, where logistics mattered more than armor thickness, where speed of replacement mattered more than perfection. The Germans walked away from the testing ground, understanding a truth they had not wanted to face. The Americans were not improvising. The Americans were not lucky. The Americans were not careless with design. They were simply smarter about what war required. And the M3 half-track, a machine that looked ordinary and unremarkable, had exposed that truth more clearly than any tank duel ever could.
When the German engineers finally compiled their full technical report on the captured M3 half-track, they expected it to be filed away, perhaps studied briefly by staff officers, and then forgotten. After all, it was not a tank. It did not carry thick armor, nor did it mount a powerful gun. It was not a Tiger or a Panther or even an SDKFZ-251. It was just a troop carrier, just a support vehicle, just a machine meant to move men from one point to another. But as the evaluations moved upward through the German High Command, something surprising happened. The M3 half-track did not disappear into an archive. It spread. Commanders, strategists, and production officers all read the same uncomfortable conclusion. This machine, plain and unimpressive at first glance, offered the clearest explanation yet for why the Americans were gaining momentum across every front. It was not the vehicle itself that mattered. It was what the vehicle represented. In the final analysis, the Germans understood that the M3 was not simply a tool. It was a mirror, reflecting the industrial and strategic philosophy that made the United States unlike any other nation at war. While Germany poured resources into highly specialized vehicles that required expert craftsmen, the Americans produced an army built around machines that any factory could build and any soldier could maintain. The M3 was the embodiment of that philosophy. Simple, reliable, fast to produce, easy to repair, universally adaptable. German officers who read the report realized that this philosophy extended far beyond the half-track. It shaped American tanks, artillery, supply trucks, aircraft, and even the smallest infantry tools. The United States had created a war machine that did not rely on flawless engineering, but instead on intelligent engineering. A design approach where the question was not, how do we build the best possible machine, but how do we build the machine that can win a long war? The Germans looked at their own situation with growing dread. Every panzer built in Germany consumed precious time, materials, and manpower. Every half-track required precise welding,
complex armor shaping, and specialized parts that could only be manufactured in specific factories. Every breakdown in the field required trained mechanics and replacement components that were increasingly difficult to deliver. Germany was fighting a war of quality in a world that demanded quantity. The Americans were fighting a war of quantity with machines designed for quality through simplicity. This realization did not sit well with German pride. Their officers had long viewed their engineering as the gold standard of warfare. But the M3 showed them that victory did not belong to the nation with the most complex machines. It belonged to the nation that understood production. It belonged to the nation that could replace losses with speed. It belonged to the nation whose vehicles stayed in motion while others broke down. The report included one line that many German officers read more than once. The strength of the American army is not in any individual machine, but in the system that produces them. The M3 was a perfect example of that system. It was built in such vast numbers that the Americans could afford to lose dozens without slowing down. Factories back home were assembling more every day, using parts sourced from hundreds of companies across a continent-size industrial base. There was no single bottleneck, no single point of failure. Germany could bomb a factory, but the Americans had 10 more producing identical components. Logistics officers saw another danger. The M3 allowed American infantry to move faster, farther, and more safely than foot soldiers or truck-transported units. A German infantry division took days to reposition. An American mechanized infantry battalion could move in hours. The M3 gave the Americans the ability to surge forward when opportunities arose and to withdraw with minimal casualties when needed. It turned infantry into a mobile force that Germany could not match on a large scale. Even more alarming, the Germans realized that the M3 formed the backbone of American combined arms tactics. It carried radio operators, engineers, medics, supply teams, anti-tank crews, and reconnaissance units. Wherever the Americans needed manpower or equipment, the M3 delivered it. That consistency made their operations faster, more flexible, and more coordinated. It was not a glamorous machine, but it was the glue that held the American battle plan together. One German general wrote in a private note that the M3 explained more about American success than any tank battle or bombing raid. He wrote, "Their vehicles are everywhere. They never stop arriving. It is as if the Americans have endless roads made of steel and rubber." But the most painful realization came from a senior engineer who had spent years designing armored vehicles for the Wehrmacht. He studied the M3 with arms crossed, silent for a long time. When he finally spoke, the men around him understood they were hearing the truth Germany had refused to acknowledge. He said, "We build for perfection. They build for war." That statement summed up the entire strategic contrast. Perfection was slow. Perfection was expensive. Perfection broke easily. Perfection was fragile. War demanded speed. War demanded replacement. War demanded endurance. War demanded simplicity. The Americans built machines that matched the demands of war. The Germans built machines that matched the ideals of engineers. And so, as the testing concluded and the M3 half-track was parked in a corner of the depot, its hull dusty and its paint chipped, the Germans understood that they had not captured a small victory on the battlefield. They had captured a warning that the war they were fighting was already unwinnable. A warning that the United States had built an industrial machine Germany could not compete with. The M3 half-track was not the most powerful vehicle of the war. It was not the fastest. It was not the most armored. It was not the most feared. But it was the most revealing. It revealed why German supply lines faltered while American ones surged forward. It revealed why American divisions seemed to multiply across every front. It revealed why the United States could fight a global war without exhausting itself. It revealed why the Americans were winning. In its plain steel hull, in its truck-derived engine, in its simple suspension and modular frame, the M3 half-track carried a message that even the most stubborn German officer could no longer ignore. Victory does not always belong to the nation with the brightest engineers. Sometimes it belongs to the nation with the smartest ideas. And the M3, in all its practical simplicity, proved that the smartest idea of all was building a machine that any soldier could fix, any factory could produce, and any army could trust.